Hi, Edmund here. I'm gonna do a video. Haven't done one for a while, and I figured that this is the time I can do one. Um, it's about the lime shaper that I'm building to 1/8 scale from the original, and this is the base here. This is a solid block of mild steel, 2 inches thick and about 12 inches long by 8 inches wide, and it weighs about 60 pounds. And these slots, in a previous video I showed how I did these slots on the little Taig milling machine here. It's quite a task, and I had to do a few modifications to the machine. For instance, new pulleys and a bigger belt, and it worked out okay. It was a bit of a struggle, but awful lot of weight hanging out on the milling table. So I'm at the stage now where I've got the cross slide, or the travel of the ram across, and the frame that's fixed underneath it so that it will sit down on this surface. And the original had it was a cast. It was done in the early 1900s, so at that time they cast everything, and so it had a relief out here and down right the way across, so that a bolt could go down from the cross slide, and the frame that the cross slide sits on, you'll see that in a minute, and it allowed them to get a nut underneath here to tighten it down. Now I'm reluctant to hog all this out with the weight on the little Taig milling machine, so I've come up with a new idea, or another idea. I worked on hard-inch lathes for about 18 years, and there was a feature on the top slide that I really was impressed with, and when I bought the Taig lathe and tried to fit the cross slide onto the top slide onto the cross slide, it was a struggle. It was flimsy and it was awkward, and it didn't work very well. So I took a page out of the hard-inch design of their top slide and how it fits onto the cross slide, and it works as a pin with a cam screw or bolt, a cam bolt that goes through the side of the bolt of the shaft that oh boy, I'm getting confused now. Anyway, I've kind of copied that idea and just scaled it down to suit this particular project. So I'll swing round now, and I'll give you a little bit of information about what I'm actually doing at the moment. So let's swing round, and we're at the mill now, and hope that's pretty good. Okay, this is the frame that sits on the main base. It's upside down. Okay, that goes that way 180, and here is the top slide, or the cross slide, where the ram travels backwards and forwards. So because of the size of the mill, I had to try and adapt to suit the size of the mill, in the sense that this would have been a complete block of cast iron, and it would have been machined as one piece. My buddy down in California, he did that, but he has a slightly bigger milling machine. So I've gone the other way, and I've adapted the fitting of two parts. The frame, which is in 3 blocks, 1, 2, 3, and I scalloped out these 2 side blocks. I machined out the radius to suit the underneath of the cross slide, and then I've got a 40 thou lead shim underneath, between the base of the cross slide and the radius of these 2 blocks, and that's a 40 thou shim. I've also got a dowel in each block, a 3/8 dowel that goes down through into the cross slide, and I'm hoping that will give me a constant if I ever have to take this off, and I'm going to have to take it off to do another operation soon, when I finish this. So I've got 3 blocks joined together, and locked in on the cross slide. And now what I'm doing is, let's see, what did I do with it? Here. Okay, so I'm going to show you this. This is a 1/2 inch drill rod, and at the top end here you'll see I drilled it through and bored it out to a 0.4 diameter, and this is the part that is going to locate this base onto the main base, and lock it down solidly. And this is the system that Hardinge has with their top slide on their HLV lathes, and it works very, very well. So the other part that goes to this is this unit here, which is again scaled down, and it's an eccentric cam, okay, and it's a 25 thou eccentric. So you have a 3/8 surface here, diameter, and a 1/4 inch here, and then of course you have the cam which is there. Now what happens is that this will eventually go down into this 1/2 inch hole that I've just bored out, or bored and reamed, and it goes down so far, and this cam goes in the side on the center of this hole. Okay, so I can place this eccentric bolt, we'll call it an eccentric bolt. I can place it anywhere up and down in the face of this unit, and I'm going to place it in the middle or central. So when that cam is in there like that, central with this hole in the bolt, clamping bolt, then when this is sitting in here like this, and you move the cam or you move the cam bolt, it's going to move this. It's going to move this shaft up and down, in the direction that you move the cam. And in doing that, I will determine a distance from that center to somewhere down here, where this will sit. Let's undo this again. Let's see where we are. Go to the base again. I know this is not very professional, but anyway. So anyway, this now will be sitting from the cross slide and the frame. This will be in there like that, in that frame. And when this comes down here, I'm going to transfer the holes from the frame down through here, 1/2 inch holes and ream, so it's a nice fit. And on the underneath, I'm going to mill a slot about 1/4 inch wide plus a few thou, and then when I've got everything set with the cam working at the top end here, I will then determine where this 1/4 inch dowel is going to go through. It's going to go through this shaft down here, and the idea is it will sit recessed in the bottom of this block, and it will be loose. Everything will be loose until you turn this cam, which lifts this bolt, and as soon as the 1/4 inch dowel that's across there, as soon as that makes contact with the bottom of the slot, then when you turn the eccentric more, just a little bit more, then the 3/8 shaft here will actually pull the cross slide and frame down and clamp it solid on this surface. So that's how it's going to work. I did it on my Taig cross slide, and this is going to allow me to, if I ever have to remove it, to put maybe spacer blocks underneath and make it extra rods, then I can easily take everything off from the top, and I don't have to turn the thing over to undo screws or bolts, nuts or whatever. So that's basically, I hope you can understand that. You probably can't, but so I've already bored this one out and reamed it to size, and now I've moved over to the other side, and it's on 6 3/8 centers, and so now I've opened it up to with a 7/16 drill, and I'm now starting to bore out to about maybe 10 thou undersize, and then I'll just put a 1/2 inch reamer in there and finish it off with a reamer. So I'll show you what I'm doing now. I'm at the stage now. This is a boring head that I saw in the Model Engineer. I think no, it wasn't. It was Mechanics, I think. And this is a sleeve that revolves, and inside there's a gear which engages with a, where are we here? which engages in here, or is it there? No, that's there, yeah. And it engages with a cog that is attached to a 40 thou thread that moves the tool in and out. It's it's only got about ½ inch range, so it's a small one, but so when you're adjusting it for a cut, you unlock the side here, or here, where are we? Yeah, here, and then you move that round. There's a scale on here. You move that round, and I think it's 10 thou a cut removed when it goes from one long line to the next long line, and it's just a nice size for this mill. The only thing is that it's rather long, and it just sits on a 3/8 spigot at this end, so it kind of vibrates a little bit when it's boring, but it does the job. It's a single tip tool, and it does do what it's meant to do. Kind of a neat little thing. If I'd have thought about it before I followed the directions, I could have made this shorter, this section here shorter, and maybe I could have put a bigger spigot in there and used one of the A to Z adapters that screw onto the metric ER16. But that's beside the point now. I'm not going to bother now. So anyway, I'll start it up, and I'm using Mach 3 to feed the Z-axis down, because it gets very tiring reaching up here and doing it by hand. So I think I've got it all set up, and it's going to bore down to 1.25 inches before it reaches the bottom end. So okay, I'll switch it on, and we'll start it up. I've already set it for a 10 thou cut. Now, it won't take a 10 thou cut because there's spring, so you usually have to take maybe 2 or 3 passes at the same setting to get some kind of a size and trueness. So it's a little bit, it's not like a big machine where you've got a big head and lots of solid setup. It's all a bit flimsy. It's, you know, it's sticking down that far. You got a little mill, so you've got to adapt to what you've got. So I've got this. Where are we? I've got this hand control that I purchased. It doesn't do everything, but at least I can get a feed going and save the effort of doing it by hand. So okay, let's hope it all goes well. Okay, I've got it feeding down. Now, nothing's fast. Now what's going on? Come on. There's a slight bit of chatter there, but it's basically cutting. It's just a a cheap tool bit as well, boring tool. It's one of those Busy Bee Chinese crappy carbide things, but they do work. They're not too bad. I've got a diamond grinder that I built for resharpening, so it goes quite well with carbide. So when it gets down through, I won't reverse it and bring the tool back up, because it does chatter. So I just stop the machine and wind it up. It's quicker to do it by hand. Okay, now I'll put another cut on. So undo the clamp, bring it round to the light so that I can see the scale, and just move it round 10 thou, or it should be 10 thou. I haven't used this for a long time, so I'll lock the clamp up. Okay. Wind it down to 0. 0. So I've got about 40 thou to remove. Now, I wouldn't normally do this, but I have to do that because it just makes a terrible noise when it's coming back up. It's because of the shape of the tool bit, I'm sure of that. It doesn't have a, it just has a slight taper on the side, and it's not a proper boring tool that I know of. Okay, now that's that. Right, we'll put another cut on. Where are we? There. Yeah, there's about another 10th after this. It should be getting close. Okay, did I lock it up? No. Right. Okay, there's that. And that. 0. Put the machine on. And you know what? Before I go any further, I'm going to cool off, and I'm going to withdraw the tool and move the carriage, move the X over so that I can measure that and make sure that all is well. So I'll switch off and I'll come back later. Thanks for watching. There.